we can see reaction with the compound of oxygen. When SO2 gas is burned in presence of oxygen, there is a formation of SO3 gas. This reaction form on the basis of contact process for the manufacturing of sulfuric acid. With now we can see its reaction with hydrocarbon. When methane is burned in the presence of oxygen, it gives us carbon dioxide and water. These reactions are called combustion reaction and highly exothermic in nature. That's why hydrocarbons are used as fuel. Now we can see its uses in our daily life. In addition to its importance in normal respiration and combustion process, oxygen is used in oxyacetylene welding, in the manufacturing of many metals, particularly steel. Oxygen cylinders are widely used in hospital, high altitude flying, and in mountaineering. The combustion of fuels, example hydrazines of liquid oxygen, provide tremendous thrust in rocket. Now we see oxide. A binary compound of oxygen with another element is called oxide. As already stated, oxygen react with most of the element to form oxide. The oxide vary widely in their nature and properties. Oxides can simply or mixed. Simple oxide can be classified into on the basis of acidic, basic, and amphoteric nature. Acidic oxide, an oxide that combines with water to give an acid, is called acidic oxide. For example, SO2 gas is react with water, it gives us H2SO3, that is in aqueous. As a general rule, only non-metal oxide are acidic, but the oxide of some metal is highly oxidation state also have acidic character. Now we see basic oxide. The basic oxides, the oxide which give a base with water, are known as basic oxide. In general, metallic oxide are basic oxide. Amphoteric oxide, some metallic oxide exhibit a dual behavior. They show both of the acidic and basic oxide, show such that they are known as amphoteric oxide. They react with the acid as well as alkalis. Some example are there: Al2O3, ZnO, and PbO react with acid as well as base. Now we see neutral oxide. These are the some oxide which are neither acidic nor basic. Such oxide are known as neutral oxide. Example of neutral oxide, that is CO, carbon monoxide, NO, N2O. Now we discuss ozone. Ozone is an allotropic form of oxygen. It is formed from the atmospheric oxygen in presence of sunlight. This ozone layer protects the earth's surface from the excessive concentration of ultraviolet radiation. Preparation को देखते हैं अब हम. ozone is obtained when silent electric discharge is passed through pure cold and dry oxygen in a apparatus called ozonizer. During the reaction, conversion of O2 into ozone is 10%, and therefore the product is called ozonized oxygen. Since the reaction is endothermic, silent discharge to produce less heat and prevent the decomposition of ozone back to oxygen. Structure of ozone. The central oxygen of ozone is sp2 hybridized, containing a lone pair of electrons. As a result, ozone has an angular structure with a bond angle 117 degrees Celsius. Now we discuss its physical property. Pure ozone is a pale blue gas, dark blue liquid, and violet black solid. Ozone has a characteristic smell, and in small concentration it is harmless. of nascent oxygen. It acts as a oxidizing agent. For example, oxidizes lead sulfate to lead sulfide to lead sulfate and iodide to iodine. When ozone react with an excess of potassium iodide solution buffered with a borate buffer, iodine is liberated, which can be treated against standard solution of sodium thiosulfate. This is a quantitative method for estimating O3 gas. Now we discuss its use. Ozone is used as a germicide, disinfect, and for sterilizing water. It is also used for bleaching oils, flour, starch, etc. It acts as a oxidizing agent in manufacturing of potassium permanganate. Now we discuss little bit sulfur. Allotropic form. Sulfur form numerous allotropes of which the yellow rhombic alpha sulfur and monoclinic beta sulfur form are the most important. The stable form at room temperature is rhombic sulfur, which transform to monoclinic sulfur when heated above 369 Kelvin. Compound of sulfur. First has sulfur dioxide. Sulfur dioxide is formed together with a little 6 to 8% sulfur trioxide. When sulfur is burnt in air, sulfur in solid form, oxygen gas, it is burned in air, sulfur dioxide is formed. In laboratory, it is readily generated by treating a sulfide with the dilute sulfuric acid. Now we can see its property. Sulfur dioxide is a colorless gas with pungent smell and is highly soluble in water. It liquefies at room temperature under the pressure of 2 atmosphere and boils at 263 Kelvin. Sulfur dioxide, when passed through water, form a solution of sulfurous acid. It readily reacts with the sodium hydroxide solution, forming sodium sulfite, which then react with more sulfur dioxide to form sodium hydrogen sulfide. In its reaction with water and alkalis, the behavior of sulfur dioxide is very similar to carbon dioxide. Sulfur dioxide react with chlorine in the presence of charcoal, which is act as a catalyst to give sulfuryl chloride, that is SO2Cl2. It is oxidized to sulfur trioxide by oxygen in the presence of vanadium oxide, that is a catalyst. Now we discuss when moist sulfur dioxide behave as a reducing agent. For example, it convert iron 3 ions to iron 2 ions, decolorize acidified potassium permanganate solution. The later reaction is a convenient test for the gas. Now we discuss its uses. Sulfur dioxide is used in the refining of petroleum and sugar. It is also used in bleaching of wool and silk. It is also used in anti-color, disinfectant and preservative. Now we discuss sulfuric acid. It is a oxoacid of sulfur having molecular formula H2SO4. Industrial purpose of manufacturing of sulfuric acid. These days, the sulfuric acid is mostly prepared by the contact process. The acid produced by the method is free from arsenic impurities. Sulfuric acid is manufacturing by the contact process, which involves 3 steps: burning of sulfur and sulfide ores in air to generate SO2, conversion of SO2 to SO3 by the reaction with oxygen is in the presence of catalyst vanadium oxide, and the third one is absorption of SO3 in H2SO4 to give helium. Now we discuss its uses. It is used, firstly, it is a very important industrial chemical. A nation industrial strength can be judged by the quantity of sulfuric acid it produces and consumes. Is needed for the manufacturing of hundred of other product and also in many industrial purpose processes. The bulk of sulfuric acid produced in is used in the manufacturing of fertilizer, that is ammonium sulfate, superphosphate. The other uses are, first one is petroleum refining, manufacturing of pigment, paint, dye stuff intermediate, detergent industries, metallurgy application, cleaning metals before enabling, electroplating, galvanization, storage batteries, and in the manufacturing of nitrocellulose product, and as all laboratory reagent. Thank you. Have a nice day. Hope you or understand very well.